Beneath the shifting light of the open ocean, an octopus glides across the seafloor with almost no sound. Its body has no bones to support it, no protective shell to hide inside, and a lifespan that, for many species, lasts only a few years. Yet this soft-bodied hunter performs feats that seem almost impossible. It solves problems, escapes carefully secured enclosures, and vanishes into its surroundings with astonishing precision. How did such an unlikely animal evolve, one of the most extraordinary forms of intelligence in the natural world? Our cameras follow a common octopus as it emerges from a rocky crevice at dawn. Every movement is cautious. There is no herd to offer protection, and no partner standing guard. Alone, it must constantly balance the search for food against the risk of becoming food itself. In this demanding environment, survival depends not on speed or strength, but on making the right decision before danger arrives. At first glance, its movements appear effortless. 8 flexible arms spread across the rocks, each exploring a different path. Suckers press against shells, stones, and patches of algae, gathering information long before the animal commits to a direction. The octopus is not simply touching the world around it. It is continuously collecting chemical and physical clues that reveal what cannot yet be seen. Unlike the brains of mammals or birds, the octopus nervous system is distributed throughout its body, while a large central brain coordinates overall behavior. More than half of its neurons are located within the arms themselves. Each arm can process sensory information and perform complex movements with remarkable independence. Rather than issuing every command from one central control center, the octopus delegates much of the work to its own limbs, allowing the entire body to solve problems simultaneously. This unusual design offers a powerful advantage. Coordinating 8 endlessly flexible arms through a single brain would require enormous processing power. Instead, each arm manages local decisions while remaining connected to the animal's broader goals. As the octopus searches among rocks, one arm investigates a narrow crack, while another steadies the body against a current. Others continue sensing the environment, creating a constantly updated picture of the surrounding world without slowing the animal's response. A sudden shadow passes overhead. Before the predator comes into view, the octopus freezes. Its skin begins to change. Brown becomes gray, smooth becomes rough, and the outline of the body dissolves into the texture of the rocky seabed. Within moments, the hunter becomes almost impossible to distinguish from its surroundings. This transformation is driven by millions of specialized pigment cells called chromatophores, working alongside reflective cells and muscles embedded within the skin. The brain rapidly coordinates these systems to adjust both color and surface texture. Vision provides continuous feedback, allowing camouflage to match nearby objects with extraordinary speed. Instead of escaping through movement alone, the octopus often survives by convincing predators that it was never there. Camouflage does more than prevent attacks. It also turns the octopus into a patient hunter. Remaining nearly invisible, it slowly approaches a crab searching for food among scattered shells. At the final moment, 8 arms explode forward in perfect coordination. Powerful suckers secure the prey, while a sharp beak hidden beneath the arms delivers the decisive bite. Intelligence here is not displayed through dramatic action, but through careful timing, precise control, and an understanding of opportunity. Not every meal follows the same pattern. Different prey demand different strategies, and the octopus adapts accordingly. Some shellfish are pried open through persistent manipulation. Others are drilled with the beak before digestive enzymes weaken the muscles holding the shell closed. When obstacles change, behavior changes with them. This flexibility allows octopuses to exploit food sources that many predators cannot easily access. Learning quickly becomes one of their greatest advantages. Young octopuses receive almost no parental guidance after hatching. There are no experienced adults teaching hunting techniques or safe hiding places. Every mistake carries real consequences, making the ability to remember successful solutions essential. Laboratory studies have shown that octopuses can improve their performance through repeated experience, solving increasingly complex tasks after learning what worked before. Our cameras shift from the open sea to a marine research facility, where scientists carefully observe octopus behavior under controlled conditions. Presented with sealed containers holding food, the animals examine every surface using their arms. Some twist lids, others remove plugs, and many discover efficient solutions after repeated attempts. These behaviors demonstrate flexible problem-solving rather than simple instinct, revealing an ability to adapt to unfamiliar challenges. Even more surprising is their curiosity. Faced with new objects, octopuses often investigate through touch before making any attempt to feed or retreat. Their arms explore shapes, textures, and movement from multiple directions at once. Because each sucker can detect both chemicals and physical contact, exploration becomes an active process of gathering information. Curiosity itself may improve survival by helping the animal understand unfamiliar opportunities and potential threats. Scientists have also discovered that some octopuses recognize individual human caretakers. In controlled studies, animals responded differently to familiar and unfamiliar people, even when clothing was similar. Recognition likely depends on a combination of visual cues and repeated experience rather than emotional attachment. While research continues to explore the limits of this ability, the findings suggest that octopuses build detailed memories of important features within their environment. Memory becomes especially valuable when escaping danger. An octopus squeezed between coral branches can instantly reshape its entire body. Without bones, almost every part is soft and compressible. As long as the hard beak at the center of the body fits through an opening, the rest can usually follow. Crevices inaccessible to most predators become secure refuges where the animal can disappear within seconds. This remarkable flexibility has also produced some of the ocean's most famous escape stories. In aquariums around the world, octopuses have slipped through tiny drainage gaps, opened unsecured lids, and returned to neighboring tanks after hunting fish. These events are not evidence of supernatural intelligence. They reflect an animal evolved to examine every possible route through a constantly changing environment, where discovering a single overlooked opening can mean the difference between life and death. Some species go even further by carrying tools across the seafloor. The veined octopus has been observed collecting discarded coconut shells and transporting them for future use. Alone, each shell offers little protection, but when assembled later, the two halves create a portable shelter large enough to conceal the animal inside. This is considered one of the clearest examples of tool use among invertebrates because the object is collected, carried, and saved for a future purpose rather than used immediately. Such behavior reveals an important pattern. Octopus intelligence is not centered on one extraordinary talent, but on combining many smaller abilities into flexible solutions. Distributed control, sensitive arms, advanced camouflage, learning memory, and physical adaptability all reinforce one another. Evolution did not produce a single brilliant feature. It produced an integrated survival system capable of responding to almost any challenge the ocean presents. Yet one mystery remains. If octopuses possess such remarkable intelligence, why do they live such short lives? Most species survive only 1 to 3 years, and many die soon after reproduction. Unlike long-lived mammals that gradually accumulate knowledge across decades, each octopus must develop its abilities within an extraordinarily limited window of time. Natural selection has favored rapid learning rather than long life, allowing each generation to quickly master the immediate demands of its environment before passing its genes to the next. This strategy reflects the unpredictable world they inhabit. Coral reefs, rocky shores, and coastal habitats change constantly with tides, storms, predators, and shifting prey. There is little advantage in relying on fixed behaviors alone. Instead, evolution rewarded animals capable of making independent decisions based on current conditions. Intelligence became not a luxury, but an essential survival tool for a creature with few physical defenses. Modern neuroscience continues to uncover new questions about how octopus cognition works. Researchers are investigating how distributed neural networks coordinate decision-making, how arms process information independently, and how memory is stored across such an unusual nervous system. Many answers remain incomplete, reminding us that some of the ocean's greatest discoveries still lie ahead. As the sun begins to set, our octopus returns to the shelter where the day began. Its colors soften to match the surrounding stone, and its outline gradually disappears into the reef. The ocean grows quiet once more, leaving little sign that one of nature's most sophisticated minds was ever there. For millions of years, evolution shaped an intelligence unlike our own. It did not emerge from large bones, long lives, or complex societies. It arose from constant danger, endless adaptation, and the need to solve problems every single day. The octopus reminds us that intelligence is not defined by how closely another species resembles us. It is measured by how effectively life discovers new ways to survive, even in forms we would never have imagined. In the silent world beneath the waves, one soft-bodied hunter has rewritten what it means to be truly intelligent.